So now we will talk about the PSC Composite Girder Bridge. When we do the real project, the modeling time takes so much time because there are some challenges. Let's look around these challenges and how to make them easy. The first challenge is the various PSC girder type. You can see this various type girder in the pictures. So we need to consider this the type of girders, and the second challenge is girder for the curved or the skewed bridges. If we have the curved or the skewed bridges, we need to calculate the influence and make this model. And the third thing is various PSC sections. We also have to consider these shapes, and also sometimes we need to use the irregular sections. In this case, we have to take a longer time to calculate the section properties, and we reflect this one to the software. And the number fourth is the quick tendon placement. Okay, we saw the four challenges, and I want to ask you one thing. How can you handle these challenges in the real modeling? Actually, it's not easy. The model time in actual project take around 2 or 3 days. However, in the MIDAS Civil, we can reduce it to the half a day. The key is PSC Composite Wizard. Okay, we're gonna check this Composite Wizard. The Composite Wizard have 5 tabs. The first tab is the layout. Okay, we can see the layout is the wizard, and in this the tab, firstly we can see the girder type and the modeling type. We can select the girder type, precast or the splice, and the modeling type. When we want to make the model as a beam, only the beam elements, we can select the all frame. Then this wizard will automatically create these beam elements as the model. This is one example from the MIDAS Civil. And the second option is the mix between the beam element and the plate element. So this is also the example from the MIDAS Civil. We can handle this element type here. And the second option is for the skewed and the curved options. So we just input value for the angle, and we can set the skew and the curved. Here is the two options. One is the same spacing and the offset spacing. We can see the figures when we click the guide button. Then we can select this option. Here is the examples from MIDAS Civil. So this MIDAS Civil reflect all the conditions, and it will generate the curved and the skewed model automatically. And the next one is a curved radius. Just input the value and that's it. So no need to spend time a lot for this calculation. Just input the radius value or the angle value, then it will generate all the things. And the next one is for the substructure. Just check on the substructure and select the material and the sections, then it will generate the whole model. Okay, let's say about the substructure interaction. When we need to consider the substructure interactions, sometimes we have to make the model superstructure and the substructure separately. However, the MIDAS Civil has the total the modeling and the analysis the functions, so you don't need to make the model separately. Just select the option and it will generate the whole model. And the next tab is about the sections. In the section tab, you can set the material and the section shape. Input the value, the number of girders and the materials in the section. And also here is the girder information. You can input this information. Not only the one span, but also the various span can be set here. input the start and the end value, then you will generate a lot of the spans in here. And define girder sections. Click this one. We can select the for composite section, the I type, T type, PSC type, or the general type. And sometimes we need to use the irregular sections, right? How can you use the irregular section? That is not if that is not in the software. Sometimes we have the trouble. But in the MIDAS table has SPC sections. So just make these irregular sections on the CAD first, and then we can export and import it to the SPC module. And you will calculate all the irregular sections properties, and this properties data and the irregular section shape can be imported to the MIDAS civil. So the MIDAS civil has the very flexible functions in this irregular section. And the next step is about the tendons. The tendon assignment, we can select the tendon type, halved or curved, and input the value, the number of the tendons, or just a transverse distance. And then we can see the accurate location in these figures. We can check these specific locations. And here is the strong point in the MIDAS civil. The MIDAS civil also can support the 2D view and the 3D view. When we check the 3D model view, we can see the 3D model view. But the important thing is here. When we set the tendon, if we make it larger, and we can see the specific location in the total model. So the MIDAS civil is a very strong, the high graphic, the model. So just we can check easily the tendon location and the tendon shape. Okay, this is the explanation of this wizard, and now we're gonna move on the software, and I will do the demonstration. Okay, today we're gonna make the model 2 spans PC composite bridge. And I already explained about the GUI system of this MIDAS civil, and we're gonna look around this initial data. I already set the initial data, the material sections, and the time dependent material setting. First of all, the materials. I set the concrete, the Eurocode, DBC 35 and 45. We can select the code and then use the database of this concrete. And also, if you want to use the user-defined system, just select the none options on the standard. Then the value window will be opened. So just input the value, then we can use the user-defined material. And also I set the tendon. And the A sections are here. I set the girder section and the pier and pier cap sections. And here is the time dependent material. Okay, the code is a CBFIP 2010. I select this code, and also we can see the various code in this the time dependent material. Click this show result, and then we can check the time dependent material graph. And set these initial things, and we're gonna move on the structure and PSC composite bridge wizard. In the middle we can find this function and click the button, and the composite girder bridge wizard we can see. And now we're gonna open the initial data. I already made the information. Okay, it means that we can save these informations of the wizard, and also when we want to use the previous data, just click open and call the saved file. then we can use the previous data. So it's very useful and you can easily save it. I already mentioned about the functions on the layout tab and the section and the tendon. So in the section tab, I input the girder, number of girders, the 5 girders. Input the locations and the span. We're gonna make the 2 span. So here are the 2 span information. And also you can add more the span information so that it will create various and longer the span bridges. Tendon, and if you click the guide, you can check the tendon guide, the half shape, half 2, and curved. I choose the curved shape and then input the number of tendons and the information in here, and just it will create the tendons. So the next step is about the load. In here we can set deck width, and also we can set the pavement and the varial width. Input is the value and we can figure it out what is the parameter for in the deck. So we can check that one and input the value. And the middle of this wizard we can find the dead load option, and the bottom of this wizard we can find the live load options. When we want to consider the dead load, the before composite or the after composite, just select dead load cases that you want to consider and then input the value. Then it will reflect all the dead load informations. It's for the superimposed dead load. And the live load, the define moving load case, and here we can set the code and define lane, and here is the figures, and we can check it from the left side. We consider this the left side and then input the distance, the lane 1, lane 2, lane 3, 4. I input the 4 lanes, and the next one is for the defining vehicle. Just add the standard, and I already selected the Eurocode, so we can see the Eurocode standard, the vehicle. The road bridge, I'm going to use the default value and click OK, and that's it. And the next step is about construction stages. I'm going to use the default value, and if you want to change the value for this duration, yes, you can change the duration. The 5 stages for the long-term effect. You can check the construction stage description and the duration and change this value. And then click OK. Then it will create the whole model with the substructure. This you can easily create the composite girder bridge. Think about it. When you do this modeling project, how many times you take for this modeling? Actually, I input some value, then I just click button, then it will automatically create the whole model. So it's like a magic. And I'm gonna introduce about the model. The first thing is the sections. I set the 8 sections, and also here is another sections are created. In the mid part, I'm going to use the sections later on, and you can check these sections. And the next one is the tendon profile. We set the tendon in the wizard, and the whole tendon information are reflected to this model. So we can check it, the tendon line in the 3D model view, and if you click the hidden view button, then you can check the tendon location specifically. The line model view, we can see it, and I'm gonna disappear this tendon. Okay, we saw the tendon profile, and the moving load also are input this model. And I want to introduce the one thing. the one strong functions named the tapered section, because I set the different section shape in this the model between the middle part and the support part. You can check the different section size, because we in this case we need to make the tapered section. And think about it, when we make the tapered section, how can you solve this one? Actually, we have to change the section size, right? So I also want to change the section size first. And change the selecting option, the x-axis, and click the top view. And I'm going to select the whole model. And then it will automatically consider only the x-axis and select the x-axis element in the nodes. Activate only this one, then we can see the girders only. And now I'm going to change the section here, the between part, and change the section. Just drag and drop. Then we can easily change this section. And the right side part, I'm going to select the elements and drag and drop. And that's it. You can change the section size. I think it's very intuitive functions, and I'm going to make larger. And we can see the different shape of the elements section. The I end and the J end, because I set this section size differently in the I end and the J end, so each element has this different section size. And next, what we need to is to calculate all the interpolation length, right? So we have to open the Excel sheet, or by using the hand calculation, we need to calculate the tapered section size. But the MIDAS civil has the tapered group, this wizard function. Just only select these tapered section elements, and you can see the list, and just input the group name. And here are two options, linear or the polynomial. Select the option, and then I'm going to show you the features. You can see the different side, and click just add button, and then we can see the automatically change the taper section. So that's it. No need to calculate the interpolation length. Just select element and input the name and click add, and that's it. Not only the concrete sections, but also the steel section can be done in this tapered group, so you can easily change that one. Not only this the section, this mid section, but also the vertical section can be changed by using the tapered group. So you can easily change and control the model. And now we're gonna check the model again, the 3D whole model. And we already set the construction stages. So now we will check the construction stage setting. Okay, the first stage, click this first stage. In the first stage, I already have the model for the substructure, so we can check the pier and the pier cap. And we're gonna move on the next stage, stage number 2. In the second stage, I have casted the girders here. So now here, if you go to the girders, you will see that the girders are actually tapered girders. So here you can see that the support section is different from the middle sections. And there are transformation sections between them. We already set the taper section. And we're gonna move on the stage number 3. You will see that the extra load has been added. I'm gonna display the wet concrete load. So the load cases also will be changed based on the stages. So each stages has all the load cases. We can see this change in the work tree menu. So we can see this dead load. And this extra load actually belongs to the dead load of the slab. It means that the slab has not been casted on the beams. There is no stiffness of the slab. But the load due to the slab, it has already been applied on the structure. And we're going to move on the stage number 3 too. Then you will see that the stiffness of the slab is activated in these stages. And the next stage, number 4, we have added some other loads, so the spur imposed load. You can see the imposed load on the work tree menu. So the final stage, stage number 5, which is actually the long-term stages. So in long-term stage, we have used it for the 10,000 days. We can see this the value. The duration is 10,000 days. It's around 30 years. So this is how we have created these stages for this bridge. And if you talk about the section properties, then we can even see the section properties that have been used for the particular bridges. Okay, I'm going to move on the base stages and on display the wet concrete. In the base mode, we can see the information imposed the static load and the model this part. Okay, so now what we can do is input another load. We already input the dead load and the moving load, and also if you want to consider the other load here, we can input the additional load. I'm going to use the RS, the response spectrum functions. You can use the response spectrum function. Just click this function and click add and click the design spectrum and select the code. The MIDAS table has very strong point in the seismic load. So we can do the static dynamic response spectrum analysis and time history analysis, and also we can consider the base isolator analysis. Not only the pushover, we can use the seismic load can be used in the MIDAS table. So we're going to use the Eurocode base graph in the response spectrum and click OK. Then you can see this one. Or just you can use the spectrum time. I just selected the elastic spectrum, that one. But normally we use the design spectrum for design. So now I'm gonna create the design spectrum again. And the other parameters are here. You can change the value, the peak ground acceleration and the importance factor, behavior factor. And click OK, then it will generate the design spectrum. And click OK and click close and click the RS load cases. Now we're going to assign the response spectrum function to the model. I'm going to set the name as the RX. It's about the x-axis. So we're going to use the 0 value degree and then check on the Eurocode design spectrum. We already made it. And then click the eigenvalue analysis control. In here we can see the 3 options. And now we're going to use the long course option and input the number of frequencies. I'm going to input the 10 value and then click OK and click add, and that's it. And for considering the Y direction, we're going to change the name RY and change the angle to 90 degree. Because the x-axis, for the x-axis we use the 0 value, and for the Y direction we're going to use the 90 degree value. And click add, because the options are the same with the x direction. And that's it. We set the response spectrum analysis data. So we we make the model and we created this model by using the wizard, and the boundary conditions are here. Also, they were created by the wizard. Sorry, I'm gonna display it. Then you can see this support, and also on display I'm gonna to display the elastic link and the rigid link here. So this boundary condition also generated automatically by the wizard, and that's it. So now what we can do is analysis, run the analysis, then it will calculate all the things. And to save our time, I already prepared the completed model. So we're gonna move on the completed model, and we're gonna check the post-processing, the result. You can check the tapered section model, and it's same with the previous model. And the result tab, you can see the load combination first, and click the concrete design and click auto generation button. Then here are various type of code. Select the specific code that you want to use and click the OK button. Then it will generate the load combination automatically. You don't need to manually create the load combination. And also it opened the manual functions. Just you can input the name, the load combination 3, and select the activate the strength checking or the serviceability checking, and just you can input the load and the factor. So here is the manual functions. You can easily control the load combinations here. And now we're gonna check the result. The first one is beam forces. I'm gonna click the beam diagram and select the load combination 1, and we're gonna check the moment first. Solid fill and the legend, and click apply. Then you can see this the legend, 3D graphic result. You can check the beam diagram. Not only the moment, in the other the forces can be checked. The shear force. Okay, I'm gonna check the moment, apply, and okay, we're gonna see the result for the stages. Based on the stages, it will show you all the result. So I select the stage number 1, and I'm gonna select the dead load and click apply. Then we can see the value and the diagram, and change the stage number 2. The stage number 2 is the tendon. Here is the tendon, and on the stage number 3 there is no deck, only the wet concrete dead load. You can check the values. The values are changed depend on these stages, so we can check it. And stage number 3.2, in here we can see the slab, the deck, and number 4 and number 5, the last stage. And each stages we can check the load cases, the dead load, erection loads, and tendon, creep, primary or the secondary load, and the summation things. So the secondary load is the real load. So we're gonna use the data for the design, and the primary is the imaginary the data. So but the MIDAS will support the both, so you can check the both data. And here is another the stronger point, the result table. Click this result table and click the composite section and click the beam forces, and we can set the load cases and select the stages and click OK. Then it will show us the actual force and moment Y, moment G, the data, specific data as the table format. So in here we can select some part or the whole table and copy and paste to this other document, or here is another options. The export to the Excel sheet. click this button, then it will make the Excel sheet. Okay. And I want to show you the very strong point. I think you might like these functions, the tendon. MIDAS Civil has a very strong result table about tendons. When you select the tendon result table, then we can see the tendon coordinate, elongation, arrangement, loss, approximate loss, or the stress limit check. So I'm gonna select the one thing, tendon loss. You can see the whole tendon result as a table, and the tendon losses, you can see the result depend on based on the stages. So the change the stages and click apply, then we can see the each stages the data. And the best thing is here the immediate loss. It means that it will show us the short-term loss effect and the long-term losses. So we can check the both and all the tendon losses in here. Okay, this is the tendon result. And sometimes we make the model as the mixed elements between the plate elements and the line elements. In this case, it's very hard to check the plate element forces because the plate elements show us only the stress-based result. So in this case, we can use the bridge girder diagram. The MIDAS Civil has the options to check the forces, so we can use this function very usefully. And check on the last step. I'm going to show you how to use that one. Select the dead load and forces and the group. Because I already set the group in the one girder. Sorry, the initial data, this group. I select this girder line and make it the group. And click the bridge girder diagram again. And select forces and the group for this girder line. And click apply. Then it will show us the forces diagram. You can easily check this diagram, and also you can capture it, and you can use it for the making the presentation or the report. So no need to check the stresses, no need to calculate the forces. So just see that one and use this value and the graph. Okay, we're gonna check the moving load result. Here is the moving load tracer in the MIDAS Civil. You can select this one and click the beam forces and moment. Okay, here is the option beam forces and moment, and we can see the load cases, the moving load max and the minimum value. And also we need to check the post construction stages and input the key elements. I'm gonna select the one key element in the middle, the 153. That element is here. We can see that this girder location, and I'm gonna select this one and select the components that you want to check. And I select the MY and then click apply. Then it will show us the tracer. So this is the maximum value for the moment Y. And also I'm gonna check off this hidden view, then we can more easily check the diagram. And also we can check the shear force. This is a maximum, and for the minimum we can check it. So this is the moving load functions in the MIDAS Civil. Also the MIDAS Civil has another strong point called the concurrent forces. So in the moving load, not only the maximum and minimum value, but also we can check the concurrent forces value as a table. So this is another functions, and a lot of users using the MIDAS civil because the concurrent versus table format. Okay, now we're gonna move on the design tab, the PSC design tab. Click the PSC tab and you can see that the design code in the asset code, euro code, and the other codes. We can check it and click the parameters. Then we can select the options, the ULS options and the SLS option. In here that this, of course, we can check this the ultimate state and the serviceability limit state, hold the things. And also sometimes we need to check the specific part. In this case, you can specify the checkoff and the check on that you want to check, and just click OK. Then you can check only that the selected state. And we can check this one, and here are another options for the PSC design data, the material and the position and serviceability load combination type, and short long-term load cases, and its product class shared connector. Select that the parameters, and then you can set it. Then we can perform the design. I already performed the model, so we're going to check the result table, the flexure strength. In here we can see the table format result, the OK sign and G sign. It will show us the different color, and easily can check the NG remarks, the red color. And also here is the checking option for the shear design, the shear strength design. Okay, we can see the OK sign and the NG sign as a table. So this is the table format result. And sometimes we want to check the specific element design result, and also we want to see the how to calculate this design data. So in this case, okay, for example, this one, the element, we can check this element, the design report. And here is the option, the Excel report. When you select the element and click this Excel report button, then it will generate the detailed report for design. And here is the example for it. I already selected and export this specific design detailed report. The element number and the position information. You can check it. And the design conditions are here, the number 1 chapter. You can see that here are the section information, section figures, and the material information, and the slab information. And below that one, you can see the ultimate moment resistance checking. So the strong point is that one. The MIDAS civil show us the whole calculate procedures. So we can see the all the parameters and what value are used for these parameters and what equations are used in this design calculation. And also on the right side, we can see the specific location on the code chapter. So we can see the design result and the table and how to calculate this one, and the remarks, OK or NG sign. Okay, here is the one thing, the NG sign. If you find the NG sign, we need to make them the right. So in this case, we have to check the code chapter and change the missing value. I think the strong point is this one, what equations and what value are used for this to design the calculation. So check the code chapter, and we can easily find the code chapter. Check the parameters and the equations, then we can easily find the missing point. So here is the whole procedures from the modeling to the design in the MIDAS civil. So I already show you the specific functions of the MIDAS civil, and I think you can get the ideas how to make the modeling easily and how to make the design easily in the MIDAS civil. And also, I think you might get the strong point in the MIDAS civil. So now we're gonna have the Q&A session. And if you have any other questions and if you want to know about the MIDAS civil, please contact us. And here are our email, the eusupport@midasit.com or johnmin@midasit.com. Please contact us and we will answer about your question. Thank you for joining. Thank you for participating our webinar.